Hi, welcome to Distinti Behind the Scenes. I've been on vacation for the past 2 weeks and I've been working as busy as a beaver building instrumentation to help us win the new electromagnetism application series. The reason why I decided to do that is because the video I put out where I was discussing Ken's experiment was one of the best videos as far as pulling in traffic. And so I figure, well, all right, let's do some more videos on new electromagnetism applications so people can see the value of new electromagnetism with, so that's where I decided to go. Take a little break from ethereal mechanics, which is good because, as I discussed in one of the videos in the new electromagnetism application series, or I will, is that the two of the terms of magnetism, terms 2 and 4 of new electromagnetism, was inherited from classical theory. And I never really tested it. And this application that we're going to do, which is going to be a railgun, I'll say that right now, we're going to go very thoroughly. It's going to be slow and boring, but we're going to do the full engineering and step by step and construct a very efficient railgun. Okay, I figure a railgun's a pretty cool thing to do, and it'll hopefully bring in a lot more people because it's a wide interest thing. I guess people are excited about things that go boom. And so what we have here on the table is one of the instruments that was derived. This is a precision current source. This current source is designed to sink very precise amount of current up to 10 amps, so it can dump the entire power from this power supply. And therefore, by dumping a current into an armature, a test armature, we can understand the full and very precise behavior of the railgun that we're going to design. And thereby, once we understand the behavior of the railgun, we can design an optimal driver circuit for the railgun. Now what this is this got a little Arduino hidden underneath all the leads here. It's acting as a function generator. And right now it's programmed for 2 seconds on, 2 seconds off to dump a ½ an amp. Okay, and we got one current meter in line, and you can see it go to 4.9 and then to 0 and then to 4.9. So that's 2% accurate according to this meter. And then this meter here is set up in series. It's got 7 turns wrapped around its sensor. So this should read 3.5 amps. And 3.46, I should have allowed more time on the Arduino. 3.44, so that's 0.49 amps when you divide by 7. So right off the bat, without doing any calibration of this circuit, just buying good quality components, the D to A converter in here is a very precise D to A converter with a very precise band gap generator in there, and then the resistors being used to measure the current are 2% or 1%. So that we're within 2% without doing any calibration is very, very good. So this circuit is ready to go, and the timing of this circuit is over here. The green shows the command from the Arduino to load the A to D converter. The blue is the output of the op amp that drives the FET, the power FET, and the gold is the current stabilizing across a sense resistor. And from the scale you can see here is 10 microseconds per division. And from the command to go, this thing is stable at least in 40 microseconds, which is pretty good. I'll take it. But again, this thing is designed to drive a full 10 amp load through our test armature so we can evaluate what an optimal drive circuit would be for the railgun. There's more circuits we're developing for this. Over here is a very precise force meter, a very expensive little device. Can measure down to 1/100th of a Newton. And this is the drive circuit. I don't have it built into a table yet, but there's going to be a force table. And so the idea being, with the magnet table, we're going to quantify magnets and know their force and their energy. And then with the drive circuit, the very low current drive circuit, we're going to drive an armature with a known amount of current for an extended period of time. and hook that armature up to a force table and very precisely measure the force. And by doing that, we'll validate the models of new electromagnetisms 2 and 4. Because they're the ones that are going to tell us what the force should be. And as long as we get within 2 or 4%, because all this stuff is good quality stuff, but it's only going to get me to within 4%. As long as we're within 4%, then I'd say that the models are good, and then we can use the models to develop the full-up railgun and develop the full-up drive circuit, and then we'll have a pretty interesting demonstration. And unlike railguns you've seen probably in other places, this railgun is not going to have all the smoke and flame associated with it. It's going to be very efficient. Because in the rules of acquisition, if you've got a lot of smoke and flame coming out of your railgun, then you're not putting energy into propelling the projectile. So that's where we're going with all this stuff, and that's what I've been building and moving toward. I figure let's do something fun to excite the masses, and then we can drive back into ethereal mechanics and find out how new electromagnetism really works. Thank you for your patience, and thank you for your time. Thank you for your donations, and really, folks, I appreciate that I've been offline pretty much because of work. I'm hoping that that's going to settle up within the next couple of months, and I can get back onto a normal schedule. Anyway, thank you very much.